Welcome, Calc students. We are in the process of going through Chapter 3, and we're looking at derivatives. Currently, this tutorial right here is going to focus on Section 3.7, which is implicit differentiation right here. So I'm going to jump out of this page, and we're going to go into our notes. And let's go ahead and begin the implicit differentiation. So what is implicit form versus explicit form? If we take a look at our two columns here, this right here is explicit, y equals 4x squared plus 3x minus 3. This is implicit, 2x squared plus y, 2y squared equal to 1. This is explicit, implicit. And the last one here, u equals 3w plus 5. That's written explicitly. So hopefully you guys can see the difference between the two. Implicit form is not solved for a variable. It's going to be written with x's and y's or s and t's or any kind of combination of variables that are not solved for one of them, like explicit. There's times when we have an equation that is written implicitly and you have to take the derivative. Here are two problems that are very simple to rewrite implicit or explicitly. So for example, the first one is xy equal to 1. If you solve for y, you can get 1 over x, and I'll rewrite that as x to negative first. And then you take the derivative, it's simply negative x to negative second, or negative 1 over x squared. That was pretty straightforward, no problem. The next one, 4x plus 2y equal to 10. I can take the time to rewrite that explicitly. That's pretty simple to do. Actually, you're going to subtract the 4x on both sides. And then you're going to divide everything by a 2, so y equals negative 2x plus 5. And when you take the derivative with respect to x, it will be a negative 2. Okay, so that's pretty straightforward. When your equations are written implicit, you can rewrite them as explicitly to take the derivative. However, there are going to be times when it's just too difficult to solve for a y, and actually in some cases you're not going to have the knowledge of how to solve for y in this calc book. So for this example right here, it is not worth taking the time to solve for y. What we're going to do is learn how to take the derivative implicitly. So I have a couple of examples to walk us through this. If I have 3x squared plus 2, and I say take the derivative, what I'm actually saying is take the derivative with respect to x. I am taking the derivative of this expression with respect to x. That's what the differential divided by dx. So if I do that, I'm going to do it the long way. I'm going to write this out as d over dx times 4x cubed plus d over dx times 2. And then you're going to take the derivative, and you're going to end up with this 12x squared dx over dx. You took the derivative with respect, so it's dx over dx. Now, we never wrote that before. Let me keep going. And the derivative of 2 is a 0. I'm taking the derivative with respect to x, so I write dx over dx. Now, we never wrote that before because obviously dx over dx is a 1. It cancels out. So that's going to equal 12x squared plus 0, or just simply 12x squared. Now, why are we talking about that? Well, because the next one, if I have y cubed minus x, and I ask you to take the derivative with respect to x, then I'm asking take the derivative of a y cubed with respect to x. And the second part is take the derivative of x with respect to x. So when you take the derivative of y cubed, nothing new there. It's just a power rule of 3 comes down, y squared. But this time, it's a dy over dx. I'm taking the derivative of y. So it's the differential of y with respect to your dx. So in the second part, it will be minus the derivative of x is a 1 dx over dx. And when you clean things up, your answer is just simply going to be 3y squared. Dy dx does not go away, and then your minus 1. So when you take the derivative of a y, you just have to remember to include your dy dx. So for example, the next one, I ask you to take the derivative of this expression with respect to x. Then you're going to get, let's see here, 8x cubed plus 28y dy dx plus 2 dy dx. So every time you take the derivative of a non-x, a y, you're going to have a dy dx back. Just for example, say you had the Pythagorean theorem, a squared plus b squared equals c squared. And I ask you to take the derivative with respect to x. Then it would be 2a dA dx plus 2b dB dx equals 2c dC dx. So that's how you are going to take the derivative implicitly. There are 4 steps for taking the derivative of an implicit expression. Step 1 is differentiate both sides. So I just write that as, that's my little symbol for differentiate both sides. Send all dy dx's to the left-hand side. So I'm going to get all my dy dx's on the left side. I'm going to factor out, and I didn't have an example, I didn't do that yet, but I'm going to, if you do have multiple dy dx's, you're going to factor it out. And then obviously we're going to solve for dy dx. So there are 4 steps in solving. I'm going to stop this tutorial here. I'm going to pick this up in my next tutorial. We will do our couple of examples right here, and I'll see you soon.